Good morning, ladies and gentlemen. In this video, we will be solving question number 2189B from CodeForces round 1075. Yeah. So the name of the problem is the curse of the frog. So let's read the question first. Understanding the question and especially this question is pretty important. Because in the contest, while I had given the contest, I had I was pretty confused. Uh, by the meaning of by what is by the meaning of the question. And yeah, so uh, let's read the question first and understand. On an infinite number line at point 0 sits a frog. Okay, after many years of meditation, the frog has mastered n unit types of magical jumps. The ith type of jump allows it to jump forward by no more than ai units. In other words, if it was at integer point k, after the jump, it can land at any integer point from k plus I. Okay? But magic always comes with a price. It has been cursed. Before each BI attempt, this is pretty important. Before each BI attempt, uh, to use the I type of jump, the frog rolls back CI units. Okay? In other words, if it was at point K, it will first find itself at point K minus Ci, and after the jump, it can land at any integer point from K minus Ci to K minus Ci plus Ai. Okay. The frog's goal is to reach the point with the number x using jumps while minimizing the number of rollbacks. Help the frog find the minimum number of rollbacks it will have to endure on its way to go to the goal, or determine it cannot reach the point x. Yeah. Okay, so the test cases lie in the range of 1 to 10 raised to the power 4, and n ranges in the range 1 to 10 raised to the power 5, and x ranges. This should be a clear indication that we have to use long. X lies in the range 1 to 10 raised to the power 18. And okay, how is the format of the input? First of all, we will have n comma x for each test case, and each line should contain AI, BI, and CI. Okay. Now, what was the meaning of AI? AI represents the maximum amount of jump. BI represents, mm, yeah, BI represents the attempt, the number of attempt. Yeah, and CI represents the rollback. So, our task is to somehow find out a solution which is somehow in the range of big O of n log n, as the sum of n across all test cases does not exist 10 raised to the power 5. Let's have a look at this test case. Okay. First of all, before going through the test case, I would like to dry run what is going on. Yeah. Let's use this test case 1 comma 7. Okay. 1 represents the number of jumps, or the number of magical jumps he has learned, the frog has learned. And the description of the jump is given as 4 to 5. 4 is A, 2 is B, and 5 is C. So what does the question actually mean? So initially the frog is at point 0. In the first jump, um, it can it can land at any point from 0 to 0 plus 4, and for simplicity we'll just say that it lands at point 4. It tries to cover as much distance as possible. Yeah. So Now let's say we want to jump one more time. But the thing is, this will be a second jump. So before the BIth attempt, yeah, before the BIth attempt, so before the second attempt, we have to roll back by 5 points. Yeah, so roll back. And we have to roll back by 5 points. So obviously, 4 minus 5 is minus 1. And again, as we have rolled back at the second attempt, we can roll back some 4 more points. And the maximum point which the frog can reach in a single cycle. I hope you understand what do I mean by cycle, because now what do I actually mean by the cycle? Let's say um, yeah. Now I can jump one more time. I can jump from 3. Let's write it. Yeah, over here. From I can jump from 3. 2, 3 plus 4, that is 7. This is my third jump, and before the 2 BIth jump, what do I mean by 2 BIth jump? 2 into 2, that is 4. Before the fourth jump, I should roll back by 5 units. So yeah, this is roll back, and this is my fourth jump, and I can again jump by 6. So as you can see that the difference between the coordinates after the rollback is actually 3. you know so if I have to plot it on a graph, uh, uh, the coordinates look somewhat like this. The coordinates increase, then it decreases, then it again increase, then it decreases, then it again increase, then it decreases. So the point when the number of jumps, let's say I have to reach, let's say 5. So what is the minimum number of rollbacks required? And the answer is 1 rollback. Why? Because first of all, these 2 jumps are free. I will explain to you what do I mean by free. So I have reached already the fourth point, and I have to just cross. I have to just gain one more uh, coordinate, or I have to cross one more coordinate in order to reach 5. So the difference in me and my between me and my target is actually 1. So as you have seen that between 2 rollbacks, the coordinates between 2 rollbacks is 3, and we can calculate it by a into b minus c. This is just plain simple mathematics. So what is a into b minus c? 4 into 2, 8. 8 minus 5 is 3. Yeah. So we are forming a cycle. So, after a single rollback, okay, uh, as you can see, before the first rollback, let's say the coordinate is, let's say, 11. So let's say um, the rule, let's say, okay, let me formalize it in a mathematical language. Let's say before kth rollback, my coordinate is, let's say, m. So before k plus 1th rollback, just a second. My coordinate will be m plus a into b minus c. Yeah, isn't it? Why? Because in a single cycle, we are moving forward by a into b points, but because of the rollback, we are moving backwards by c points. Yeah. So as you can see, I hope that you understood the question. Let's dry run through all of the test cases. So 1 comma 1 and 3 3 3. So what's the target? It's 1. And the B is 3. So as you can see that the B is 3, I can jump for 2 times without a single rollback. So I can jump 3 into 3 minus 1, which is 6. I can jump till 6 without a single rollback. And as you can see that 1 is smaller than equal to 6. So the answer will be directly rollback equal to 0, because we didn't even had a single rollback during this process. Now let's consider the situation when n is equals to 1, 4 to 5. Now what is the what will be the starting point, or what are the free jumps before the first rollback? What is the coordinate which I can reach? And the answer will be 4 into 2 minus 1. So the answer is 4. So I can reach 4 before the first rollback. Yeah. And as you can see, what will be the difference between the coordinates of two rollbacks? And the answer will be 4 into 2 minus 5. So 8 minus 5 is 3. So yeah, 0 to 4, there will be a rollback. So minus 1, and yeah, again. So 3. Now from 3 to 7, I can go. Then there will be a rollback. 7 minus 5 is actually 2. And 2 plus 5, 2 plus 4 is 6. So as you can see that the difference between, as you can see that there's cycle which is being formed. Yeah. And these are the, these are the peak positions in a cycle. Let's say this is a single cycle. So we have to, we have to find out the minimum number of rollbacks. So if I were to ask you a question, how many rollbacks are required in order to reach 3? Your answer shouldn't be one rollback. Why? Because even before this rollback, we can reach 3, as we have already reached 4. One more crucial information is that we can jump at any integer from k to k plus I. That is pretty important, because if it were not the case, then the problem would have been much more complicated. Okay, so yeah, I hope that you understood why are we considering the coordinate only before the rollback. Yeah, why? Because it is the peak position. I hope you guys are getting what I mean. So yeah, and this is the reason why I'm calling these jumps as free. The first two jumps, not the first two jumps, the first bi minus 1 jumps, because we didn't have any rollback for these jumps. And let's say if someone asks me what is the number of rollbacks required to reach 8, let's say in this case, so my answer would be, as you can see, that in a single in a single cycle, I can jump by 3 points at max. And by from the first two jumps, I have reached at the starting point 4. So the difference between 8 and 4 is 4. And as you can see, 4 by 3. So it would be somewhat 1.333. And if 4 is not divisible by 3, as you can see that indeed 4 is not divisible by 3, then we have not actually reached the point, or I can say we have not actually reached the coordinate 8 after the first rollback. After the first rollback, you know what I mean? So this 0.33 indicates that I need to, jump one more time, at least one more time. You know what I mean? So I need to go and cross this rollback as well. So yeah, so this is what I mean. I have to round up, not round down the integer, not round down the division. I have to round up. So yeah, 4 by 3 is 2. So as you can see, the two rollbacks are required. One mistake which I had done while solving the problem was that I started my cycle either from the beginning of from the cycle or from the end of the cycle. But uh, the important thing is I have to, I hadn't noticed that before the rollback I was at my peak position. So that, that lack of observation was, crucial. And yeah, I hope you guys understood why are we, cycling from, bi minus one attempt to bi minus one attempt to three bi minus one attempt. Yeah, let's let's check this. This is an interesting question. 2 4 1 comma 2 comma 4 2 comma 2 comma. Now the thing is, what is the difference between the two cycles of this, of let's say ith jump, where I equal to 1, and as you can see, um, 1 into 2 minus 3. So 2 minus 3 is actually equal to minus 1. Let me try run this test case. So we are at initial position 0. We will reach 2. Then we need a rollback. Then we'll reach um 2 into 1. Yeah. No, no, not 2. I'm sorry. I will reach at coordinate 1. Then there will be a rollback, and I will reach at coordinate 1 minus 3, which is minus 2. And after this rollback, I will reach minus 1. As you can see, we are going back in direction. And yeah, this is not good. Why this is not good? Because uh, we will be, after each and every cycle, we are actually moving back by 1. This minus n indicates that we are moving back by 1. Let's say what is the value of, let's call this a into b minus c as, let's say, k. What will be the value of k for this I equal to do? You can see the 2 into 2 minus 4. So 4 minus 4 is actually 0. Let me try run this. It's 0. We can go to 2. Because this is a free jump, I can go to 2. Then there will be a rollback. After the rollback, I will be at minus 2, and then I will reach 0 again. So we are always stuck in this loop. So as you can see that after utilizing the one free jump over here, that is 1 plus 2 3. So the max starting point which we can reach is 3, and there will be a continuous downfall after this. Why? As you have seen that the value of ab minus m, or ki for I equal to 1 and 2, is either negative or 0. So we'll be not making any progress. So we will not reach 4 anytime in the future. So the answer is minus 1. This is an interesting test case, and after this test case, everything will be crystal clear. 5, 8, 12, 1, 11, 10, 1, 4, 1, 1, 3. 1 comma 2 comma 5, 2 comma 1 comma 7. So what's the value of k1? The value of k1 is 12 into 1 minus 11. So k1 is equal to 1. K2 is equals to 10 into 1 minus 4. And the answer will be 6. What's the value of k3? 1 into 1, 1 minus 3 minus 2. What will be the value of k4? It will be 1 into 2, 2 minus 5 is minus 3. What will be the value of k5? 2 into 1 minus 7, and the answer will be minus 5. As you can see that there are only two jumps for I equal to 1 and I equal to 2, where the k is greater than 0. So only out of these two is contributing to our progress. And logically, by the principle of greedy, we should use this uh, I equal to 2 jump only. Why? Because it is our duty to minimize the number of rollbacks required. Okay. One thing which I would like to highlight is that we have to use the free jumps for each and every jump if possible. Now, what do I mean by free jumps? Now, let's say that we have to use we have to use the first jump, but there will be a rollback for the first jump. So we will be at 0 point, then we'll be rolled back to minus 11 point, and minus 11 point, and then I will reach 1. But the thing is, what do I mean by free jump? The meaning of free jump is the maximum point which I can reach without any rollback. So obviously, for each and every case where bi is equals to 1, free jumps don't exist. But for bi greater than 1, we can jump ai into bi minus 1 for free. What do I mean by free? Without any rollback. That's it. So as you can see that for I equal to 4, bi is greater than 1. So bi is equal to 2. So 1 into 2 minus 1. Yeah. So the answer is 1. So I can reach the point from 0 to 1 without any rollback. Now we will move for now we will try to first of all we will check if this starting point is greater than x, greater than equal to x. If it is, then we'll simply print then we'll simply print 0. Then after this we'll find out if there are any ki such that ki is greater than 0. If there are multiple ki which are positive, then we'll choose the maximum one. And yeah, in this case k2 is maximum, and yes, k2 is equals to 6. So what is our target? Our target is to reach 8. Our target is 8. So it's the difference between these two. The difference is 7. And what is the maximum distance which we can travel in a single cycle? It is 6. So 7 uh, divided by 6, and we will round up. So the answer is 2 rollback. Yeah. So as you have seen that it is just a simple calculation part, and I will show you the code. So yeah, first of all, I'm taking the input for n and x. Then I'm initiating the starting point as 0. Then I'm creating a vector of pair of integers and an integer. So yeah, the first pair consists of a and b, and the second element of the pair consists of c. So I'm taking the input, and yeah, I'm incrementing the starting point by a into b minus 1. For b equal to 1, uh, we are not actually incrementing the starting point, but it doesn't matter as b is greater than equal to 1. So yeah, this is always true, and this is always beneficial. First of all, we will check if starting point is greater than equal to x. If it is, then we don't need any rollback, and we'll simply continue. Then we'll check the difference. If the difference between I will check the difference between x and the starting point, and we will initiate the rollbacks as 0. Now what is the meaning of good set ind? Let's check this function. First of all, set jump. Now what do I mean by set jump? Set jump is actually a into b minus c. Yeah, that is it. And we have to find out the maximum set jump. So I'm initiating the set jump as 0 and I'm trying to find out the maximum set jump. So if this instant set jump is greater than set jump, then I'm um, assigning ind with I, and I'm reassigning set jump to instant set jump, as we have to find out the maximum set jump. I'm simply returning ind. If I didn't get any set jump, because if I didn't get any set jump which is positive, then the ind will remain -1 throughout the loop. And as you can see, if good set ind, a good set, what do I mean by good set? The set of or the magical jump which has the maximum set jump. So if good set ind is equals to -1, then we can't reach the rollback. We can't reach the desired target no matter what. So the rollbacks is equals to -1. But if that's not the case, then I'm trying to find out the here m. What do I mean by m over here? Here m is the set jump which we had discussed in the function. Yeah, that is first dot first is a, first dot second is b, and minus second it is c. So yeah, and rollbacks will be equal to diff by m. If diff is not divisible by m, if the remainder is greater than 0, then we haven't actually reached the point yet. And as we are rounding up the division, so yes, we will increment it by 1 or 0 accordingly, and then we simply print rollbacks. We will submit this question. We'll submit this code, and as you can see, we'll get an AC. One mistake which I made in this submission was that I was using int for some coordinate, but as we can simply see from the condition, um, x can go on till like 10 raised to the power 18. So yeah, it's pretty huge number and it won't fit in the integer range. I hope you understood today's problem, and yes, that is it. If you have any other problems to try, please comment, please like the video, and yes, thank you. Keep learning.